Welcome to the technical skills you need now. Are you becoming a dinosaur? My name is Brian Kafferkey, and the slides and all my content for YouTube videos can be found on github.com, bkafferkey/shared. You can see it there in the slide. And I like this particular picture because it's got the dinosaur. When I was a kid, I was big into dinosaurs. Probably a lot of kids were. And in the middle of this, I mean, the whole point obviously is dinosaurs are extinct because they didn't keep up with the changing world around them. And you don't want to be like that, right? So the things you see around the Spark, Python, R, Azure, all these things, those are the new world of technology. And I'm going to talk about what you need to know to stay afloat in this world of emerging technology and how you can really thrive if you learn the lessons you need to learn. Now, this talk was actually something I did as a joint presentation with Tom Anderson, who works with New Directions Staffing. They are a Rhode Island firm that does Rhode Island and Southern Mass, to my knowledge. I think they also have an office in South Carolina. So if you're looking for that kind of thing, I'm not really promoting it. I don't get sponsored by Tom. But because he did inspire this and we worked together on this, I wanted to give him some credit here. So there's the link. And if you're looking for that kind of, you need some help in information technology or healthcare, certainly not a bad place to check out. Where are we going? First, my disclaimer. All the things I say here are my views and my views only. They don't represent Microsoft or anyone else. It's views that I have from just my analysis of the workplace, a lot of experience in technology and developing solutions. So if you don't like it, that's okay. It's just my personal viewpoints at this point. I'm going to talk about mainframes and the T-Rex and why that's relevant in today's world of technology. Talk about your skills and a bar stool. The 3 skills you need to stay employed, so stay tuned for that critical part. Advice on skilling up, and popped in here. Forgot about the next point. And I did want to point out that you can get new skills and learn all about Azure cloud technologies and things like that by going to a pretty new platform for learning called Microsoft Learn. I have the link down there. But if you may get different language differences, etc. So the easiest way to get there, especially if you're not in the US, is just go to Bing and search for Microsoft Space Learn or Google, whatever you prefer, and you'll find it really easily. And in there you can see there's a drop down for selecting roles. So if you want to focus on data engineering or data science, you can do that. They have whole learning paths. It's based on something called micro-learning. So you can do little chunks at a time. Just do a little bit each day at your lunch hour and stuff. So it's a good way to skill up over time. And it will even create Azure resources in many cases as you go along so that you can really see how things work. So I want to start by talking about when I started in this business. And I started, believe it or not, way back the mainframe world. The mainframe world was when you worked in companies, and really only large companies at this time had computers. The microcomputers really hadn't emerged yet as anything beyond a toy. So I had one of those toys myself, an Atari 800. I had a Sinclair ZX80. I had all those early computers, which is, I think, what helped me transition when the changes came to the microcomputing industry and really transform things. But in this day, you had this, they call it a raised platform area. And my first job, I remember, was just like this, except we actually had reel-to-reel tapes and things like that up there to mount tapes for files and things. And these were central large computers. They had a room that was called a raised platform, and if anything went wrong in this place, it would actually suck the air out of the room and seal it off. Not sure what would happen if I was caught in there. That always made me wonder. But of course, you didn't work, only operators worked in that room. You'd be somewhere else connected by a terminal and be doing your work. Now, not too far into this, my environment to this, in working on mainframes, the microcomputers came out. IBM came out with the first really successful commercial computer, personal computer called the IBM PC. Now, they made a little bit of an error there because they did not own the operating system for it. They licensed it from a company Bill Gates had called Microsoft. And they left it open so that Bill Gates could then license the DOS system, the disk operating system, MS-DOS, to anybody he wanted to. So that's where you had Compaq and Dell and all these companies make compatible computers to IBM's. IBM also made the mistake of not having any special proprietary chips in it. It was kind of, they just took things off the shelf and made a computer. As a result, it was really easy for anyone else to make compatible computers. So IBM's mistake in that area actually is what created the entire computer industry, because had it stayed very proprietary like Apple did, it probably never would have become what it is today. Anyway, that transformation microcomputers was interesting to watch, because when they started to come into place and the idea of being able to do real computing work on anything other than mainframe developers, operators, database administrators, at that time we had databases like IMS and DB2, they scoffed at it. They said, no way will you be able to do the kind of security we need. You'll never be able to get the kind of scale we need. You can't do serious business work on things like that, etc., etc., etc. Those, and obviously anybody who said those things is probably unemployed now. Either they went into management, they retired, or maybe they finally woke up and got skilled in personal computers, etc. But the point I want to make is, it reminds me a lot of the cloud. In fact, now when I hear things, I think on-premises, the way people talk about that, it's the new mainframe. And I hear a lot of people say, you could never move my databases to the cloud. They'd never scale. They'd never be performant enough. They can't do the things I do. You'll never be able to move our complex, systems to the cloud, or do the things we need, or it won't be secure enough on the cloud. And they somehow believe that their on-premises security is way better than what Microsoft or Google or AWS could offer. But anyway, it reminds me of that, and I find it a bit alarming, because I know what happened to those developers, and I'm trying to come out here now as a warning. Don't let that happen to you. At least acknowledge it's a pretty good likelihood that the cloud is going to take over most of the computing resources. I think, here's my personal view, I think on-premises computing resources, the hardware itself especially, will be pretty much gone in 5 to 10 years. Most companies are already moving to the cloud. Within 5 years, you're going to see a massive amount, maybe half or more of the computing resources will be in the cloud. And I think it's going to move to the point where there's virtually nothing on site anymore. It's just a lot of good reasons I'll talk about for that, but that's what I believe, and there's a lot of shifts that are going to become part of that. So my point here is danger, Will Robinson. I used to watch a sci-fi show called Lost in Space when I was a kid, and there was this little kid on the show. The family's flying around this flying saucer in space, and they had this cool robot that would warn Will Robinson. That was his friend, and he'd say, "Warn, danger, danger, danger." There's a reboot of this, obviously, I think on Amazon too now, but it was a cool show, and that's what I'm here to do. Danger, danger. You may lose your skill set. You may think that if you work at Microsoft, as I do, you have job security. You may think if you work for Amazon or Google, or you work for some large bank like Citibank or a big insurance company. But if you followed history at all, you'll see that all these things have gone through massive market and transformational shifts. Kodak is practically wiped out, right? I don't know if they exist anymore. Big companies, Barnes & Noble has been really hurt a lot by Amazon, and they're in places, a lot of box stores that were the, Sears and Roebuck at one point was the pillar of blue chip. Things change. Most of the companies I've worked for over the years no longer exist, or have seriously reduced sizes. So the point I want to make is this. Your job security relies in only one thing ever, and that is your skills. If you are highly skilled, really good at highly in-demand skills, you will be employed, period. It just makes sense, right? If you have hot development skills and can write mobile apps and web apps and really good with Java and Python and all these tools, I guarantee you'll have work. But if you're working still as a COBOL developer on a mainframe, you might have a small market to put your skills to. So your skills are your job security. And I see a lot of people still make the mistake of thinking, I can never leave this job. This is my job security. It's like, no. If you're not careful, you'll find that very often companies you thought were secure, or even your role was secure, is not so secure. It's your skills that make it that way. So the next question. How do we know when something is really something, a technology or something we need to seriously pay attention to, versus something that is a fad, a cool technology? I mean, let's face it, we IT people, we like shiny toys. We're always like, oh, this is the coolest thing, this is the best thing ever, and then it fades away. And I think what I want to tell you is the key is it a paradigm shift? So in SQL Server, and I'll say SQL Server, but when relational databases came into existence, it was a person named E.F. Codd at a company called IBM, and he designed this whole new way of thinking about data, and he called it a relational database kind of model. And he thought about it in terms of like Venn diagrams and sets of data, very dynamic, very easily to pull data from different sources, join it together, etc. And he said, and he wanted to make it very independent, so he created an entire language that you would communicate to this server called a database server, and that language was SQL, Structured Query Language. And all the principles upon which that was built defined a structure that you didn't have to even write a database. It was the concepts around it. Once that was done, IBM created a product called SQL DS, I believe it was, which was the first relational database. I'm aware of it. It was IBM's. They created the concepts. Then SQL DB2 became the next one. That's the one I first cut my teeth on for a relational database. And then things like Oracle, Sybase, and Sybase eventually on Windows became SQL Server, and on and on. You know, we've got now things like MySQL and Postgres and things. But they're all built on that paradigm. And one of the nice things about paradigms is because the concepts and the basic ideas are the same, you can go from one implementation to another. So the implementation, whether it's SQL Server or Oracle, etc., is not the critical thing. It's you're using relational technology and you can kind of move around. So paradigm's the key. If I go way back, one example, the graphical environments, the idea of drag and drop in these GUIs was kind of a paradigm shift as well. It came out of actually Palo Alto, Xerox, believe it or not, way back, had this idea of graphical environments. It wasn't Apple, actually, it was Xerox that started this in this sort of think tank, and Apple was one of the early ones to implement that in the Macintosh as a way, and then Windows came along. But here's the thing, development tools, I remember, things came along like something called Power Builder, which was by a company called Borland. They came and went. It was popular enough at the time that people thought, I should learn this. This is the big hot technology. And for a while, you could make good money if that's what you chose to do. That's a fad, though. It was an implementation. And the implementation, the idea of a GUI, that wasn't going away. But the specific technology, in this case, Power Builder, went away. You'll also see industry-specific things that are more a product life cycle, and it can be also a little bit misleading. SAP and PeopleSoft are good examples. So when PeopleSoft and SAP really started catching on fire in the market, they became very popular. They were products that were becoming more and more implemented, and as a result, there was a demand for people. So that does create an opportunity to make a lot of money, to get skilled up on those things. But because it's a product life cycle, SAP and PeopleSoft kind of did the typical life cycle. It comes up, it escalates high, sort of tables off, and then it flattens a bit. And so you might be a SAP or whatever developer, but it's kind of flattened out. It's not the hot thing it was, not because it isn't the demand there, but it sort of peaked out at a certain level of developers, and the growth is not what it once was. So those are the things to watch out for. The things like, I have my little phone here, right? I have my phone and a message there, but anyway, so I got my iPhone. iPhones themselves were the first implementation, but the idea behind the iPhone is that I have this little computer I can carry around, and phone conversations are just an app. So it was really kind of cool that the idea is I can carry this around, and now the idea that's really a paradigm shift is mobile computing. And now it's at the point where you've got to be able to pull up reports and do all kinds of work, and companies have now had to create mobile apps because that's where you are. You're the customer, and they have to move to it. So that's a paradigm shifting. Again, companies that don't follow these shifts can end up out of business. So that's a paradigm shift. The internet, World Wide Web, great example too. The World Wide Web was conceived as more of a paradigm where you have websites and you connect to them and then request a page, and there's a standard format called HTML, and there's a protocol, TCP/IP, and based on that it will give you a page, and that page could be anywhere in the world, and then it's based on the internet gets the routing. So the idea of these apps is a whole new way of doing things, and that paradigm shift is something, if you ignored it, you were in trouble. You would miss a big thing. So I hope that helps a little bit. That's how I look for things. Right now there's a lot of languages, things like Rust and Go and Swift and all these things. And frankly, I think most of them are these kind of fads, that trendy things. Some nerds like a certain tool. I really like this language. There's a lot of languages. A single language, like a new language, doesn't mean it's going to go anywhere. I've seen a lot of them over the years. I will say I think Python is an exception. I think Python is in itself almost, and maybe even a full paradigm shift, because of its level of extensibility and flexibility, and it's just kind of a piping language you could connect things with. So Python, I think, could be something that will prove to be something along the lines of like a new paradigm like SQL or something, or relational databases. So surviving the changing landscape, that's what this is all about. Things are changing quickly. We've got a lot of new technologies, machine learning, data science, and AI, and cloud, etc. And I've seen a lot of people over the years let their skills entropy. You get comfortable in a job, you've been there 15 years or whatever, and this is really the worst thing you can do in this industry, and especially now. You cannot afford to get comfortable. You cannot afford to just coast and say, I'm good in my company, I'm safe, I've been here 30 years, never had any problems, they're doing good. You're in danger if you think that, because you'll be like this person on the stool, your skills being the stool collapse, you're out on the market, you get laid off, the company went out of business, and you don't have the skills to get a new job. I've seen it happen where people, mainframe developers, for instance, ended up going into a completely different thing. They decided they had to open up a florist shop, or maybe they stopped working in a restaurant as a waiter, or whatever it takes, because they didn't keep their skills up and they didn't have the ability to transition back in. It's not a very forgiving market when it comes to skills. That's where you have to be. So here's the big reveal. What are the 3 core technologies that any data professional needs to be skilled up on? The first one is so central, it needs no introduction. It affects everybody and is extensively affecting all of industry, not just technology people. Management's got to look at this. Every industry's got to look at that. And of course, that is the cloud. You need to get skilled up on how to create assets in the cloud, how to manage things in the cloud, how do you run applications, get the concepts in your mind. Data professionals, especially, but anybody really at this point, sysadmin people absolutely have to know how to do things on the cloud. And if you're a business professional, finance, accounting, whatever, you need to go on the cloud, because that's where it's all going. And there's a lot of good reasons, but the other thing is big data. Big data is the worst name you could give something, because it's not about the size of the data. It's really about, I would replace the word big with any data or all data. Meaning you've got data all around us now. It wasn't like this 30 years ago, but now you've got your iPhone. Think about how much data is going on just with what I'm connecting to, what programs I run, what tweets I send, or what I do on Facebook, or any number of things that I can be doing. I talk to a device. I have one of the Amazon devices I talk to. There's a lot of information. What am I requesting? How good is it responding? Does it understand what I'm saying? Lots of things going on there. If you drive around, you can see that there's oftentimes video cameras tracking things like traffic and what's going on at intersections, etc. Fitbits in the healthcare or wellness industry, there's a lot of Fitbits, and Fitbits generate a lot of information as well. So the ability to leverage all of these sources is really critical and will be the differentiating factor for companies that will be successful down the road. And kind of the icing on the cake, admittedly vastly overhyped, and it's a place that is really still emerging in terms of capability. I would say of the 3 of these, it's the least mature, but offers a huge amount of benefit. We are seeing things now. You're hearing about self-driving cars, but the fact that we can talk to our phones and talk to devices, that they can give us information and predict things, etc. It's amazing. It's going to get a lot better, and it's ultimately going to be a critical piece of this. And I'm seeing a lot more of businesses that just a couple of years ago were ignoring AI starting to really take it seriously. It will be a differentiator. For healthcare, for instance, the ability to predict patients that will be readmitted can save them a lot of money, millions of dollars. It can also improve patient care by maybe looking at data that you would normally skim over and then realize that based on patient sort of metrics and things that are happening, it looks like they may be non-compliant, not taking their medications. Maybe they're at risk of a heart attack or a stroke, and there's enough information that you can go based on their medical data to predict the likelihood something will happen, so you could intervene ahead of time. And of course, things like genomics, which were really almost cost prohibitive from an AI standpoint for on-premises, could now be done because you can spin up resources in the cloud. Also, hands-off automation. You've probably heard about DevOps and things like that. The idea that everything's automated and happening without people intervening physically is critical. It's something that is emerging, and I've seen in most of my career all these manual steps people would have in their jobs. They go in every Monday and they have to run this manually and then run this and send a file out. Those days are gone. They're going quickly. For anyone who's got those types of jobs left, it will go away because it's just not acceptable from a business cost standpoint anymore. You need to be platform agnostic. It's a big shift. People say, why is Microsoft not care if you run Windows or Linux? Why do they embrace Python and Java, etc.? It's because Azure is platform agnostic. You're running on a cloud and it provides the service, and it uses virtualization and containerization to provide resources, to be able to create compute resources in a flash just by asking for it. And because of that, it really doesn't care. If you want Linux, you get Linux, and any flavor of Linux. You want Windows, you can get any version of Windows that they currently support. It doesn't matter. And as a result, you need to be platform agnostic. You need to be able to use different tools regardless of what platform they're on. But don't worry, you don't really have to get too worried about the platform, because a lot of times these services are offered in a way that you can interact with them and not get down to command level type things in Linux or something. And you need to be, and this is something, Tom, we were talking about this in our presentation, but I already knew this, but it was interesting seeing it from a recruiter standpoint, that the days of knowing like a single skill like SQL Server or Oracle are really gone, and now employers are asking for things like Python and R and SQL Server, but also Spark, and also understanding cloud. So the myriad technologies is now being demanded. You can make more money if you know these things well and get there, but you have to work at it and learn more technology than you probably have in the past. And all this comes down to, I'm going to kind of give a little selling pitch why the cloud's so critical. Imagine, I'll just use a kind of comparison here. Imagine you're in a small town and somebody gets in an accident, with a car accident, and suddenly you say, we need a hospital. Can you imagine if you could just flip a switch and suddenly a hospital appears, staffed with surgeons and medical people and nurses, all the equipment you need, and you could bring them in. Just, it wasn't there a minute ago, now it's that you bring it in and you can serve them and fix them up and everything, and then the person leaves the hospital, you flip a switch and it's gone. That's really kind of what the cloud is. It's like a holodeck for computer resources. You know, if you look at Star Trek, you can say, I need, and the interesting thing I'll explain in a minute is how it's even getting easier. You can say, I need SQL Server type capabilities in Azure. I need a large database that can store 100 terabytes of data in SQL Server database. I want it to take care of a backups, recovery, and everything. I want it to do all these things, and within minutes you have it. And then you can say 10 minutes later, I don't want this anymore. Turn it off. You don't have to buy hardware. You know, in the old days, it could take months to get the hardware, install it, and set it up. If you were setting up like a big data cluster of say 100 machines, it can be very expensive. You physically got to buy the hardware, got to have the people who can set it up and configure it. It would be cost prohibitive for any small company, but this can now be done. The cloud resources, you can do this in minutes. You can turn it off. So you can actually control the costs, and you could have, a mom and pop kind of store can now have big data processing and AI and compete with the big competitors, because it's now it's an equalizer, right? And the idea of this turning things on and off is really key. Now, admittedly, customers have to get used to the idea that there is no capital investment anymore. You don't even budget the same way. This is like using electricity. You need the computers, you turn it on. You're going to get charged while you're using it, and then it's like the electric meter. You turn it off and the electric meter stops. That's how the cloud is. It's a game changer. And when you get into it's allowing opportunities for companies to save money, but also create entire new revenue streams that weren't there. So that's why it's a huge game changer. I hope I've convinced you. Ask me more if you don't believe me. I'm going to move on. Are you ready? Do these technologies look familiar to you? Azure, AWS, Kubernetes, all these things. If these seem like, yeah, you've heard the words, but you don't know anything about them or very little, then I ask you again, are you ready? Because this is where the world is going. Now into the fun area. Where is your job role going? So I'm focusing on data-oriented jobs. So I'm going to start with the king of data-centered jobs, which is the database administrator. Database administrator, and then I'm going to look at the BI engineer, something near and dear to my heart, because I've done this for a long, long time before I moved in kind of more to big data engineering and machine learning. But the BI engineer and the database developer, where's that going? Report developer. And finally, I'll point out a couple of new opportunities that are emerging. So the DBA, these are the tasks that I think of them performing. Performance tuning, software maintenance, etc. All these things. Now you could add some other things, but what I want to really point out here is this. This can all be automated. It is automated on Azure. Not perfectly, and I know a lot of DBAs, I've had discussions and I say, well, you can't do this and it doesn't do this. But you can say, just like the mainframe days, it was true when people said you can't do this today on a mainframe. And in early points in time, they were right. It wasn't ready. But it quickly got ready. And there's a lot of motivation by the cloud providers to make it better and make this stuff disappear from a task standpoint. It saves companies money, and it lets them focus on their business. It's not a hospital's business to performance tune databases. That's like plumbing, that's like, the cafeteria. It's a necessary evil, and it costs them money. What they're there to do is serve patients, okay? These things can be automated on Azure, and it's getting better and better. So where do we go with this? What should a DBA do so that they'll have a job down the road? Well, I would suggest going towards this role. I made it up, by the way. It's not a title that I've even seen at Microsoft. But it's similar to a big data engineer, but it's really like more of a solution architect around it. So they're going to look at cloud-based development, and they're going to be looking at things beyond just SQL Server, although a really great place to start is learning things like Azure SQL DB, Azure SQL Managed Instance, and Azure SQL Data Warehouse, in addition to knowing how to use VMs and stuff in Azure. Really good place to start. Master that. That's a good place to begin. But beyond that, start looking at big data, because you can't avoid big data. Take a look at SQL Server 2019. It has Spark clusters built into it. You can create Spark clusters under it. And if I understood it right, it also scales out SQL Server so that you can have many instances and coordinate and do parallel processing even within SQL Server. So big data is now mainstream in SQL Server 2019. So great opportunity to get in there and get familiar with it, learn it, and learn it on the cloud. SQL is supported by the most popular big data platform, Spark. It's a first-class language. It's really a very powerful language. The reason they added it was because they took a lesson from relational databases. Putting SQL in it meant that by analyzing SQL statements, they could create query plans, logical and physical query execution plans. Sound familiar? It should, and that's why it's a good opportunity for DBAs who like that performance tuning to just change a little bit to scaled up performance tuning. Look at big data solution design, securing solutions, and data platform automation. So this is where I think a DBA can move to. Now for the BI engineer or the database developer or ETL, things you typically do is write stored procedures, create database objects, etc. So the idea is sort of that data warehousing and providing that business value, even doing cubes and tabular models in the SQL world. That's where it was, and that's where I've been for a long time. I had been before I got into sort of the big data space. And that's great. Where would that go? Well, and I forgot to mention also, what about things like streaming? These are the problems why you can't just stay there. Streaming, what about video and images? This is the any data, petabytes of data. A lot of companies want to look at their web logs. What are people clicking on? Where did they go? Where did they come from? That's like terabytes, petabytes sometimes of data. Python's becoming a big language in that space, and Kubernetes and Docker for containerization. I would suggest this role can be done, and I've done it, so I can tell you it's a pretty easy transition from the BI engineer to the data engineer, or big data engineer to be more precise. Focus on big data solutions and cloud technology. Look at data movement instead of SSAS. Take a look at tools like Azure Data Factory, which are designed to do the same thing, ETL work in Azure. Look at data lake design. Data lakes are becoming more sophisticated. The idea of just storing in some sort of blob storage is kind of going away, and you can have many different sources of data. You could use Azure Data Warehouse as a big data source, and that could be kind of an extended data lake as part of it. Look at Python development. Definitely cloud automation, Puppet, PowerShell, etc. is part of that, and something DBAs also use. Spark as a big data platform, Apache Spark. And now, no means not only SQL. So not only SQL options, which include things like Spark, which supports SQL. Hadoop actually has a layer on top called Hive, which supports SQL. So SQL is not gone. In fact, I would argue that SQL is probably the most important data-centric language out there still. Now, another area that I've worked a lot of times with people, but I haven't really focused myself on, is building reports. I typically build the data structures historically, and then somebody else writes reports off of it. In that role, traditionally, it was operational kind of reports. So a lot of, lists of data, and then summaries and aggregates, and then year-over-year numbers, but not visuals. So typically, business objects, crystal reports, and SSRS are typical of those kinds of tools. So on-premises reporting and very traditional. This is a great opportunity, and I think a lot of these type of developers have already made this migration, because visualizations tools like Tableau and Power BI are so popular, and Power BI has just exploded in popularity. It's an extremely hot tool. If you want to do consulting, it's probably the best thing I can think of if you want to do consulting work. There's so many companies out there wanting to do Power BI stuff. But there's differences, right? The most important thing I think you need to learn isn't even really so much a technical skill when you move to become a data visualization developer. You need to learn how to analyze the data and say, what is it telling me? Like, build the story out of it. It's kind of like you watch, a lot of these reality TVs, but they actually kind of build a narrative that creates drama and stuff on that. So you need to build a narrative based on what you're seeing. You're looking at the data and it's telling you that there's a decline in sales, and from what you can see, maybe that decline in sales is related to shifting demographics that may connect to geography. Maybe where your stores are having shifting demographics for your key customers. So it might be telling the story of you need to either realign your demographics or stop moving your stores around to be more convenient to your customers. But that ability to analyze and create visuals around it is key. And that's an art. I really respect people who can do that well. Wrangling data, you have to have some ability to pull data from different sources. It's not enough to just go for relational databases. You have to pull from Spark, you may have to pull from Azure Data Warehouse, from AWS sources, whatever. There's also a lot of complexity on the admin side. It's not just you spin up a report and then people just get it sent to them. If you look at Power BI, there's a completely very sophisticated administration facility in there that allows who can get data. How do you build reports? What dashboards can people see? How do we filter data out we don't want people to see? How do we scale it and secure the scaling, etc.? So a lot of opportunities there. So this is why it's a role that people need. And getting beyond your typical visuals, bar charts, pie charts, etc., and getting into more advanced and really interesting visuals is another key area. And to that end, knowing Python and R is a really good idea because they have very powerful visualization libraries. Often, these can be included in some of these tools like Power BI. Incorporate machine learning. Now, you don't have to be a data scientist in this role, but more and more, this visualization developer is also becoming kind of an analytics and visualization developer. And so some sort of machine learning may be integrated. And it makes sense because imagine you have this nice dashboard and you show maybe summaries and aggregations geographically of how your sales have gone this year and who where in the country. And then here you have maybe a line diagram of what's going on each year with sales. But wouldn't it be great to be able to add to that a projection, a forecasting of sales based on machine learning? So you include that and you call data out and you project this forecasting, and you can now go into future years. Very useful to management. Maybe you have a customer base, and from the customer base you make a prediction of new customers, the type of demographics they'll have, etc., and then you predict what products they will buy, and then you can actually start predicting the product demand that will happen in the next year. Really good planning tool, interesting and very insightful for management, etc. So those are things I think that are really opportunities. This is a great space, and I personally think it's great because I think it's a lot more interesting than that typical, list of columns and rows summaries and stuff. So really good space to be in. Now, a new role is to take the data scientist, which traditionally was almost not talked about a lot 10 years ago, say, sitting in a little cubicle somewhere, working independently, maybe a small group. Probably everything's happening on their little laptop, and they're working with R or Python, and they're building models, and they're doing little solutions. They're not scaling it for the enterprise. They're not using the cloud, etc. And so the transformation that they need to go through professionally is to move things to the cloud. No area is more benefited, in my view, of cloud technology than data science. And so this is an opportunity for data scientists to scale up on the cloud environment. We have a Azure, and no plugging here, but I'm actually the one working on the Azure Data Scientist Role Certification, the DP100. And this is kind of what it's targeted at, moving those skills to the cloud. Now, to do this, you're going to have the strong background in statistics. I typically don't consider myself a true data scientist because I don't have a master's or PhD in statistics. Some people think that's not needed, but I'm going to talk a little about the difference here. But the core data scientists I see as having that, so take it at face value. They define the business opportunity. These are the people who understand what data is needed and what opportunities can be done, and they really are the best, I think, to assess the opportunity. Sometimes management thinks they have what they need to do something like predict even sales forecasting, or predict what say the likelihood that somebody's going to have a stroke or something if it's medical. And they may be wrong. They may be critical pieces of information that they just don't have in the database, or it's not good and reliable data. The data scientist is a good person to evaluate that, working with perhaps other people like the data engineer. Now, again, that's the next point. They work with the data engineer. The most important aspect of the data scientist is to think out what data they're going to need, taking raw data and turn it into what's called model features, feature engineering, and that can involve a lot of things, aggregating columns. Instead of just taking raw data like person's age, they might decide to put it in bins. So they might say 10 to 20, 20 to 30, etc. That binning is a very intentional step to allow it to be used more effectively in models, picking what model, etc. Their goal is to train different machine learning models, compare them, and then pick the one that is going to work best and tweak it, etc., until they get reliable models that do the job effectively. Now I'm going to create a new role here out of my head, which is the data science operationalizer. I'll talk to in a minute. But I see them as working with somebody on their team who will take what they're doing and operationalize it in a cloud environment at scale, with reliability, with DevOps integration and all those pieces, so that they have a supportable enterprise-wide solution. Now, the data scientist should also be concerned with monitoring the ML pipeline, which is the end-to-end data to model, to make sure that it always doesn't have a drift and doesn't lose its effectiveness and accuracy. So these are all the things. I think this is a great role. It's emerging because it's a necessity. So by hook or by crook, companies will create this role and have it emerging. Finally, the Cloud Data Science Operationalizer. To be honest, if you look at my videos, I would argue this is really where I sit the most, because I have a very strong background in all kinds of data engineering work and now big data engineering work, and I'm working on the data science end, so I'm kind of in the middle. I don't consider myself to be the true data scientist because, as I mentioned, I'm not a statistician. I can get lost in sometimes, when you get into advanced statistics. I know the fundamentals. So I know how to build a model, I know how to put it through, and I know how to use tools to say, here's a predictive model that will do something. But I'm not the best at really saying, is it the best model? I'm not the best necessarily saying, what's the best way to sample the data? Should I resample? Should I be aggregating before I put it in? So those really key statistical kind of analysis work is something that I see the data scientist doing. What I see this role doing is working with the data engineer and especially the data scientist to create a cloud-based, end-to-end machine learning pipeline, something that can be supported, can use source code control, use DevOps, fully automatable, and can really make this an enterprise-wide solution that can be implemented and do the necessary low-level detail work to deploy it as well. So they're going to design and implement the pipeline. They're going to incorporate security, scale, extensibility. Now, talking about my favorite area right now, Azure Machine Learning Service, that's a whole built-in sort of PaaS service, platform as a service, so it lets you use these features. It brings the ability to create many different types of compute resources for you to do your model training, and you can determine those, as well as how do you want to deploy it. Different, and you can make them completely different. If you're not familiar with data science, a really key takeaway here is the real heavy lifting in data science is model training. You may need petabytes of data to create your model. But once you create the model, typically the model is something, it's like a little lightweight function. It's not heavy. And so you don't need, for instance, you might train a model on Spark with 1,000 nodes. You don't need that when you have the model created. You just need to run it possibly on a very lightweight machine because you have the program. So when you look at something like Azure Machine Learning Service, as just to use an example, what I know, you can do your model training compute, and you can say, this is a deep learning neural network, and I'm doing image analysis. So GPUs, which are really good at that heavy computation, the graphic GPUs, that would be a really good way to set up my compute. So maybe I take that and train it on GPUs. That would be my training compute. Maybe I look at it and say, I want to train this model and it's big data and stuff, so maybe I spin up a Spark cluster and I run my training on that. And that can all be done in Azure Machine Learning Service. For the deployment side, I may say, okay, now I've got my model. Well, I'm going to set it up, and maybe I say I'm going to create a 1,000-node Kubernetes cluster that will dynamically expand and contract as needed to service the customers that are going to consume this model. And it's going to give me a REST API, right? So that web apps and mobile apps and things like that can call it and have endpoints and security, etc. But have a way to call it. And of course, I need to build this orchestration for this whole pipeline that will build and create it and redeploy it like a DevOps, but then also provide endpoints so that it can be used. Really key area is the ability, if you build a model but you have no way to get it out there so it can be consumed, it's not going to be very useful. And that's again where the data science operationalizer comes in. This could also be called an applied data scientist. So that's another word I've heard. This person needs to be sort of that middle person who understands the data engineering and understands machine learning and can bring it all together. So that's what I'm bucking for. So and I think it's a really big new role and emerging quickly. There's a short-term opportunity for you people out there who already know a lot of on-premises ability, skills like SQL Server and admin, etc., to take what's on-premises in companies and migrate it into the cloud. I know Microsoft and I'm sure AWS have lots of special software and utilities. They're happy to help you do this, and you can make that your specialty. I'm going to help you move what you have into Azure or AWS or Google, and I'll help you do that. And that can be a specialty. While this opportunity exists, while people are moving, I call it a short-term opportunity because eventually everyone's going to be on the cloud and there won't be any migrations needed anymore. But until that happens, there's this window of opportunity where you can make a lot of money and have a good time. Generally, I see this as a consulting role because if you're in a company doing this, once you're done and you say, migration, that's what I do, they say, well, we're done, bye. So you want to make sure, you've got a longer-term plan. I see this as a great consulting opportunity. If you're skilled on premises, you got half the skills. You just need to ramp up on the cloud side of things, and then this could be a great niche. Again, short term, make sure you have enough skills that when you're done, you can sort of map out a sort of a future place to be when this is already passed. Leverages on-premises knowledge. Okay, so the point of all this, don't fall off your stool. Keep your skills up. Be ready for the new world. And I want to talk about something called the 10% myth. I made that up. What is the 10% myth? Well, I noticed that when the mainframe world started shifting, there's this assumption that you'll kind of see it gradually happen, right? It's like seeing, a piece of fruit go bad. Little by little you see it and I can see that's happening. It doesn't work like that. You might think that a little bit of a decrease in job demand is not going to be noticeable, and while it does, you'll have time. What actually happens is this. Picture a DBA job. DBA roles up until, say, a few years ago were probably growing. I'll make it something up. But we'll say that the demand is actually growing by 10% every year. So every year, 10% more people are needed to fill in that role. That puts a lot of demand on it, and it drives the salaries up, and it keeps everybody employed, and it gives a lot of room for growth and movement around. Eventually, though, if we're having what I think is happening with the cloud, and again, my friend there was telling me this seems to be already happening, that is shrinking. The demand for on-premises DBAs is actually now starting to go reverse. When it hits something, we'll say 10%, the effect is actually going to be people who have jobs are going to see there's not much demand to pull people in. It's actually a reduction in jobs out there. So they're going to stay put. And that means people who are looking are going to have a harder time than ever to find jobs. And they're going to skill up and they're going to become even more desirable because they're trying to find jobs. And it means that management's going to say, well, we have you, but guess what? There's a lot of people out there looking, and it puts stress and pressure on you. And then something happens. Maybe they decide they move to the cloud. You don't have the skills, and they lay you off. Or maybe the company goes out of business or whatever. And suddenly you find yourself unskilled and out of work. I've seen this happen many times, and it's a sad situation. My heart goes out to people when this happens. Don't let it happen to you. Do not go the way of the dinosaur. Now here's some good news, because I always like to have an upbeat side to these things. Cloud services are making technology a lot easier to use. So this is a chance to have fun. Play with these things. I look for things, I'll be honest, I look for the things in Azure that are the easiest to use. I got excited about Azure Databricks because it's easy. I don't have to worry about configuring clusters. I don't have to worry about creating hardware. I don't have to get into any files and config files and start tweaking things. I hate that stuff. I want to get in and build solutions. And so that's why I liked Azure Databricks. I'm like, wow, this is a no-brainer. They give you all the tools. You just start and build in 10 minutes. You're up and running. I did Hadoop way back. I tried to do it. I gave up on on-premises because it was so much work just creating an environment I could use. Cloud services are making things easier, and what they're doing is they're wrappering things. So if you've heard of something called platform as a service, the idea is you just use it and you don't have to worry about how it gets done and what happens. If you use things like, you certainly probably have used streaming like Netflix or something. That's pretty much that kind of service, right? You just use it. You don't think about how are they getting this to me? Where are they storing this? Same thing with like email. If you use web email, I use Outlook.com's email for stuff. And again, I don't think about that's actually more of a software as a service, but it's similar. The idea is you just use it. You don't know where they're storing. You don't worry about the computers under the covers. It just works. Something like Azure SQL DB is a platform as a service. I create my database. I create my tables. It takes care of backing things up. It'll do I think it's geo redundancy. It'll actually make copies around, etc. It can do performance tuning for me automatically, I believe, if I want it. There's all these kind of features. I don't have to worry about installing patches. It's automatically going to keep itself up to the current level for me. It's going to be available. It can allow with a few mouse clicks scale. I can change the scale of things. So I don't have to worry about those underlying things that a DBA typically has to worry about. It's really easy to use. So the takeaway there is, because it's easy to use, I really don't have to know as much. And I like that myself. I don't have to be quite as deep in some ways, but I do have to get more conceptual. I have to understand the concepts of what's going on. And you can focus now on solving business problems and adding value to the business. And that's also job security. No one wants to fire somebody who's making them a lot of money. Again, have fun. I got into this business. I had an Atari computer, writing video games. I still have the manual, I think, that was all this stuff you could do. A lot of fun. I bought other computers, and I've always just really, it's like a kid in a candy store. I think it's great. And I think you need to take that mindset to it. Have fun, learn things. It's not meant to be painful. It's not meant to be difficult. Believe me, Microsoft makes a lot of effort, as does AWS and everybody, to make it as easy as possible. So they're trying to make it fun and easy, and really do a good job. I was amazed when I first started learning cloud resources. Like, wow, do people know how easy this is? I don't want my manager to know it's this easy. So you're going to be more valuable because you deliver more value. That's really a key thing, and that's probably the watch phrase almost of this decade coming up, which is next decade too. So what I mean by that is business is going to be looking more and more. It's like, what are you giving to this enterprise? What are you delivering? If you come up with an idea and you implement it, and you suddenly created, say, a callable web service that's being charged for, it's monetized, and you're, say, a healthcare provider, and now you're charging doctors to, say, score themselves on how they're doing in terms of quality or whatever it is. Imagine now they're making $5 million a year, and they look at you and say, gosh, you're cheap to have here. We're going to give you a big raise and a bonus because we're making all this money from what you did. That's so much better than saying, what did you do? Well, I performance tuned these things. I created, tweaked these servers and installed patches. They're going to say, yeah, what did that do for us? Like, how did that help us? So this is a good place to be, and that's really what is emerging as the takeaway for any employee. You've got to deliver value. It's easy to get training, right? There's YouTube videos like this, YouTube videos everywhere, lots of great stuff. I actually like Safari Online. They have all kinds of courses. If you subscribe, it's a couple $100 a year, and you even get all their books available and stuff. So I have that. I've had it for years, and it's great. So that's a good way. But there's all kinds of online courses. There's Data Camp, there's Pluralsight, there's any number, there's Microsoft site, etc. So take a look at that. And finally, my advice. So I'm going to give you my advice from a lot of years and things I eventually came away with. The number one thing is this: never see yourself as sort of owned or a part of something. You're owned by this business, or and sometimes companies want you to say, you're a part of the XYZ company community. I don't really take that viewpoint. I always see myself as Brian Inc. So take your name, Mary Inc., whatever it is, Inc. And that means you're a business, and you need to think of yourself. How do you invest in yourself as a business? How do you make sure you're always going to earn revenue and keep things afloat? At Microsoft, I see myself as providing a service to Microsoft. And in my business, Brian Inc., I service customers. I service customers literally of Microsoft, but I also service internal customers, people that are cloud solution architects and other parts of the worldwide learning community and people in the sales area. So, and I'm always trying to build that network and make sure people are happy with what I'm doing, etc., because that's my branding. I'm branding myself within Microsoft and without. I got to be a business just like any other business. If you take on that perspective, everything else just falls into line. If you think, I can only be part of this company I've been with for 20 years, and that's who I am, and you really, get owned by that and drink the Kool-Aid and say that's all I'm about, rah for this company, and not thinking at all of yourself, you're actually doing a disservice to both the company and yourself. Learning is your right. I'm going to use this great book. If you haven't, if nothing else, read this book. Frederick Douglass was a slave in the United States prior to the Civil War. He escaped, and he wrote this narrative, and it's really fascinating because it tells the story of how he had to, in order to escape, he had to learn how to read and write. And it was illegal for people to teach slaves how to read and write because they were afraid there'd be revolt and it would cause problems. So he actually tricked the children of the slave owners with their blocks and toys to teach him how to read and write. Eventually he was able to write his own letter authorizing him as a free man and freeing him so he could escape to the north. That's not uncommon in the history of learning. Learning is such a great gift, and it's more than a gift, but it's a right, and you have to take it. Look around you and you'll see lots of examples where oppression is all about stopping people from learning, because knowledge is power, and that's why learning is your right. So power to you to learn. Learning is also your responsibility, so it's not just your right, it's also your responsibility. And what I mean by this is getting back to the sort of you Inc. I talk to a lot of people and I'll say, I'm learning Python, I'm really cool and everything, and then someone says, I wish I could learn Python, but I talk to my manager and they won't send me to the Python course I want. They won't buy me the books. They won't do this. And I'm sorry, but it's not really their responsibility. Ultimately, it'd be nice if your company and your management supported your learning. It's your responsibility. You need to do it. Go to technical events, go online, because ultimately, if you get laid off, it's not your manager that's going to have to deal with it. It's you. So you need to take responsibility for it. And it may spend a few dollars, whatever, but it's going to pay off in the long run. Keep reinvesting in yourself. Learn, buy these things, buy the books, do whatever. Have fun, go to events, try to have fun with it. And the learning will be fun as well. And get involved in the technical community. There's a group online called SQL Pass I mentioned. It's a great organization. They have thousands of chapters all over the world, and they do technical events. I speak at a lot of them. They're called SQL Saturdays. If you go on a site called meetup.com, meetup.com, they have, I don't know how many, hundreds of thousands of different types of groups, user groups and technical groups all over the world. And I have one, and what happens is on my side, I pay Meetup so that I can organize my groups. It's kind of like a much more sophisticated version of Evite. I can have members and people can join and they can see our meetings, etc. So you can find lots. There's big data groups, there's Spark groups, they're all around, and you can just join in. Most of it's free, and you can just go and network and meet people. Number one advice, and you'll see this, any sort of self-help people, if you think of like the Tony Robbins, the people say, you can achieve your dreams, they always say, don't get comfortable. Comfortable means like you're sitting there and you're saying, yeah, I could do that, but I'm safe here. I'm not going to learn anything new. I'm comfortable. It's when people get comfortable, it's like a death knell. It's the end of your career, to be honest, because that's when you're going to get most likely to get laid off and you're not prepared. So wrapping up, everything I've said, you can agree or disagree, and that's fine. My disclaimer is they're all my own views, nobody else's. So please feel free to comment. Just be polite if you don't agree, and if you like it, that's great. Mainframes and the T-Rex, again, kind of calling back. Cloud. If you got nothing else out of this, get skilled up on the cloud. Your skills in the bar still we talked about in the 3 skills, which is for the data people, the cloud, big data, any data, and AI. We talked about old to new roles mapping and how you can, if you're in one of those roles, migrate into the new world. And I gave you some advice and things. I hope you like it. Honestly, this was a bit of a nerve-wracking video because I'm afraid of offending anyone. But I also feel it's really important to get this message out to people that they need to skill up. I have friends that I had someone who did QA testing, and she found herself out of work because everything moved to DevOps and she wasn't needed anymore. And I'm really trying to avoid that for you out there. So share this with your friends. If you share in other videos with people, that's fine. But get this video, get this information to people and yourself, and just get the word out. This is important. So as usual, subscribe, connect, learn, and thank you.